So a student of mine brought this question yesterday after writing his 2026 JAMB examination, and I decided to bring it over here and solve it again. I believe it could help somebody, those of us that will be writing on Monday. So this is the question. The question says, a radioactive element decays such that only 12.5% of its original atom remains after 2 seconds. Find the half-life of the element. We've solved a question like this on the platform. If you go there and check, I said that this particular questions used to give student issues because calculation of half-life usually has the other formula for radioactivity that we use, and because of the exponential function that is not in the JAMB calculator, it makes it difficult for students to solve this type of question. So I have decided, in that class, I showed us how to solve questions like this without using the exponential function. Let's do the same here. So what should we do? We know our formula usually is n over n naught, which is the sample remaining over the original sample, is equals to exponential minus decay constant and time taken. So, but we are not going to be using this formula because we don't have the exponential function in the JAMB calculator. So I said we should change the formula into n over n naught equals 1 over 2 raised to power t over t half. We are looking for half-life, so this formula should work for us. Now it says that 25% of the element is remaining. 25%, only 25% is remaining, meaning number of element remaining is equals to what? 25%, which is 22 sorry, not 25%, 12.5%, please, sorry. So 12.5%, which meaning 12.5 over 100 of the original sample. This, if we bring this down here, it becomes n over n naught equals 12.5 over 100. So we use this related to our formula over here. So we should have 12.5 all over 100 is equal to what? 1 over 2 t and t half, right? We'll move further. 12.5 divided by 100. 12.5 into itself is 1 into 100 is 8 times, so it means 1 over 8 is equals to 1 over 2 t over t half. Now we should resolve this in indices as I have said in that class. I said we resolve this into indices. How do we do so? We have here 1 over 8 is the same thing as 2 raised to power 3 is equals to 1 over 2 raised to power t half. So this is the same thing as saying 2 raised to power minus 3 is equal to 2 raised to power minus t half. 2 goes with 2 over here. We come further here, so we should have negative 3 is equal to t over t half. We're looking for t half, so t half will be t over negative t over negative 3, and we said that the time taken is what? We said the time taken is 2 seconds. So 2 seconds, meaning this becomes, therefore, since negative cancel negative, so this is 2 over 3. If you punch your calculator properly, 2 over 3 is the same thing as 0.666. okay, so we have that. So we have our half-life is 0.6666, but our options are in minute. If you go check that question properly, you see the options are in minute, and the option is option D, which is 40. How did we get that? Multiply this is in now seconds, because the original time, the time taken is given in seconds, so we multiply this by 60 to convert it to minutes. So t half is equal to, if you punch this on your calculator, 60 multiplied by, this should give us 40 minutes. So this is the answer.